Hello and welcome back to Classic Arcade Repairs, everybody. My name is Sean, and today we're going to be looking at a Breakout by Atari 1976. This one's all TTL, no CPU on this guy, and it's a little nasty, a little on the nasty side. See, it's all pitted, corroded a little bit. I'm going to wash this thing, spray it down with some simple green, and see if that'll make it look better. Anyway, clean it up. Before I do anything, I'm going to remove this wire. I'm going to remove that for now, as I don't want that in my way while I work on this. I'm going to get this working as it originally did with the original power and everything. If you look at the wiring diagram here, you'll see up here transformer 01551. So I just happen to have right here a transistor or transformer 01551. So I have this very transformer right here that is right here. So I'm going to use that to power the board, and we'll go from there. I'm going to have to make a wiring harness for this guy, but first things first, I'm going to wash it up. First thing, somebody has recapped this thing. It's got all new caps, which is nice. I don't have to mess with caps, and the two power diodes up here have been replaced. So I don't have to mess with that. So let's go ahead and get this thing cleaned up, hopefully shine it up a little bit, and yeah, we'll go from there. And my Breakout harness is complete. As with a lot of really early Atari stuff, the coin switches, actually, the circuit goes out into the cabinet. It leaves the board and it's completed in the cabinet with the switches. You have to have both normally open and normally closed connected on both switch 1 and 2. Actually, I don't know if you need switch 2, but you definitely need switch 1. That stuff can't be floating, so you have to connect that. Yeah, so that's done. The harness is done. So we will let's hook this board up and see what we do. Monitor power first thing. Well, actually, first thing is I have to do some edge repair on this board. The edge connector was pretty bad, so I'm going to have to do a little bit of repair work. So let's go ahead and do that. Okay, and the trace repair is done. This is top side. It's just these two traces here. They both wrap around. The first two over here, these two guys right here are ground. These two are ACN. So you got ground and ACN, and both of them burned up. If I turn it over, you'll see what I did on the repair here. This one just terminates right. That one just terminates at this pad. This one went all the way up and around here. So what I did was I ran the tape up, and I just kind of tinned the tape up to there. That was all pulled up. That whole trace was pulled up where I've got that copper pad, that copper tape. The whole thing was missing. So now our edge is looking pretty good. Now we can go ahead and get ready to fire this baby up. Now, I did wash this board, and it did come a lot cleaner. But there's just some old, 45-year-old corrosion on there that's just not gonna come off. So it's as good as it's gonna get. But it'll be good enough. So So we'll go ahead and fire this thing up and see if it does anything. Okay, we are hooked up here. We got parts to parts, power, we're ready to monitor power. Let's go ahead and fire it up. 4.93, we're good on 5 volts. And it's doing something. Huh. It don't look like it's doing a whole lot. Is that a vertical hold issue or something? Let's try to mess with some pots back here. It's brightness. Yeah, I just think that's flakiness. It's not really doing much of anything, I don't think. Huh. I believe what I'm going to do with this guy is just, since it's all TTL, the whole thing is TTL, I think I'm just going to start poking around. You know? Breakout. I need to see this game. I need to see what it's supposed to look like. I think I'll do a little research. What is this thing supposed to look like? It's definitely got some funkiness going on. Well, this switch is doing a little something. I'm messing with this switch. Huh. Uh-oh. That switch really goofs it up. This one doesn't seem to do anything. This one really goofs it up. And this one just was doing a little bit, now it's not. Yeah, she just dead. Alright. I'm going to do a little research. I might read some. This has theory. There's a, the manual has theory of operation, so I'll probably read up on that a little bit. Check this thing out. Ooh, ow, ow, ow. Is that a prom chip? That is a 7474. That is a flip-flop that's way too hot for a flip-flop. Yeah, I'm gonna do a little research to kind of study up a little bit. I want to see what this looks like. I want to pull it up on YouTube or something and check it out, see what it looks like. So we'll be back. Alright guys, well right off the bat, this 74, that is way too hot for a flip-flop. Hot britches flip-flop here. This is preset, which is doing a little bit of weird. I mean, it don't look good, but it's doing something. This is going to be your data. Data is just tied high. Let me move this. Let me get this out of the way a little bit. Get a little bit better, okay? Where were we? This is data, tied high. Then this is your clock signal, which, you know, does not look great at all. Everything looks like it's lifted up a little bit. You see how it's, the offset is, it's offset a little bit. Everything's pulled a little high. This is the clear pin or the preset. I'm not sure which is preset, which is clear. They're both high, so this thing just runs. This is Q and Q not. That thing's definitely no good. She definitely bad. So there's one. I'm gonna go ahead and just red dot these things. I'm gonna just poke around this board and red dot stuff. Man, that is hot. Yeah. Yep, that's what I'm gonna do without without looking at schematics or anything. I'm just gonna red dot stuff. I'm gonna poke around, find the obvious stuff and just red dot it, even before I look at any kind of theory or anything about this. It's bound to just have bad stuff on it. So let's do that. I'll be back, guys, with probably a bunch of red dots on this thing. Okay, I'm gonna do some poking around on this thing and kind of let you follow along. I'll let you know what I am looking at, what kind of a chip I'm looking at. So far I found, let me count the red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 red dots so far. Alrighty, let's take a look. Let's look around, poke around a little bit. Alright, this is it's labeled 9316, which is it's a 161 counter. This is the clear signal, which is low all the time. Oh, I gotta turn the let me turn the game on. Okay, it's on. And there is our clear signal, which is high. Let's look at these enables. This is low. So this thing will not count with this. No, it's high and it's low. Okay, this is going high and low. That's the load pin. And this is pin 10. Okay, so this is the clock, and there's no clock. No clock. Moving on. Okay, here's a 7474 flip-flop. This is preset, which is low, which means Q should be 1 all the time. And it's not. Preset is low all the time, so Q should be set to 1 all the time. That overrides. Your data's low. There's no clock. This is clear. This is the clear signal. Unless 1 is... well, it shouldn't matter. This is always low. And this is clear or preset. I'm not sure which one it is. Huh. Well, this is Q. Q's doing this. And Q bar is doing this. That's supposed to be the inverse of Q. This thing ain't working right. It's not doing anything really. This is the other side of it. Preset is high. That's data. There's your clock signal, which is not doing anything. And that's clear. Q. Q and Q bar. So this has to be, well, now these are both high. Data's low, so Q is low. That seems to be working on that side. This board is a disaster. I don't think that there's any saving this board. Here's another 74 flip-flop. It's preset. Data is high. Clock. No clock. And no clock. That's, you know, Q and Q bar. Data. No clock. No clear. High. Low. 7400 input. Hey, finally a good looking signal. Okay, that's an input. There's an input. And a good looking output. Input. Input. Output. Input. Input and output. Input. Input. Output. That chip actually looks pretty good. One of the best looking chips I've done so far from this board. Okay, and let's do 7408 AND gate. Input, input, in, out. Input, input, out. That actually looks good. In, wait a second. Input, input, out, okay. In, out. Okay, that chip looks pretty darn good. $7411 input, 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 output, in, out, and in, out. That one looks pretty good. Okay. Here's another 7411. There's an input, 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 output, couple low all the time inputs, in, it does not look good. It's not driving low all the way. In and out. Okay. In and out. Okay, it looked decent. That one input was bad. It didn't look good. This is an LS86. This is buffering. That's a bad output. That's an input, and then the buffering input. So you got a high and a signal, and then this signal just doesn't drive low all the way. It's like its reference is too high. I don't like that. That needs to be replaced. And here's another 86. There's your buffered input, your buffering input, and then you got a floating input. Yeah, that's just a floating input. So your output is low. Input. Low. That's a bad output. Yeah, that's definitely no good. So that one's got to be replaced. And here's another 86. That is input. That's not good. That's your output. There's your input. There it is. High. There's your buffer. There's your input. And your output. That looks okay. Buffering input. Your input. And your output. Looks good. In. Nice signal. Nice signal out. Come on. Okay, there's your input. Input. Output. That chip looks to be okay. Okay. There's another counter. And then there's your clock on this counter. And the clear signal is floating. That's the clear signal. That's the clock. That's the clear signal. Here's your inputs. Got high input, high input, high input, and high input. This is pin 7, the enable. Pin 9, the load. Pin 10, an enable. And your counts. The counts actually look good. And that's pin 15, that's your carry bit. This thing actually looks pretty good. Actually looks like it's doing something. Oh, what a disaster of a board. What an absolute disaster of a board. Alrighty, I'm going to take a break for a little bit, and then I'll probably do some more probing around off camera. Alright guys, well, I've been poking around on this thing, just going around and looking at chips, finding bad stuff. So far, let's count. Red dots are bad. And white dots it looks good. The chips look good. That does not mean that they are good, because I have not analyzed any of the signals. But at least they have signals and they look halfway decent. But the red ones are definitely bad. So let's count the red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 so far. Yay. I don't know about this one. I think I might call it quits on this one. It's just too far gone. It's too bad. Look, it's on there. You know, it's got picture on the screen doing something. It's a shame. It's kind of a goofy, wavy ass picture. And this one right here, I believe, is in the either horizontal or vertical count, and one of them's funky. But look at all of this. I mean, I don't know. I mean, valiant effort by someone by capping it. But this was a lot deeper than just caps. You know. Don't know if I'm going forward on this one, guys. But I'll think about it. Not for the standard quoted price. That I can guarantee. So this one may be done right here. And if it is, I'll post it as a non-repair. But I got to get a hold of the owner of this board and give him the bad news that it ain't looking good. Man, this thing is bowed. Yeah. So, all right, we'll see what happens.